All right, so in this video, we're going to extend our location-based skills and build an app called Location Aware, which is going to show the user not only where they are, but also their speed, their heading, and their altitude. It's also going to show them their address. And so just before I challenge you to make the app, I'm going to show you how to get the user's address details from their location. All right, so we're going to move on from this app. We're not going to be using the map anymore, so I'm going to get rid of lat delta and lon delta and indeed span, and we'll just keep the location there because that's all we need. And then once we've got a location, we can use the CL geocoder. And geocoding is the process of going from an address to a location, so a latitude and longitude. We want to go the other way around, from a latitude to longitude to an address. So we're going to do a reverse geocode location, and we just need to put in the location, which is going to be the user location variable. So it's where the user currently is. And then I'm going to double click on the completion handler there. And you can see we've got an optional array of CL placemarks. A CL placemark is a way of storing address details. So I'm going to call that placemarks. And we've also got an optional error. And then they're going to exist or be used in the code below. And I've just realized that to avoid confusion, we don't actually need those lines either. We're not using the latitude or longitude, we're just getting the location directly from the location manager variable. Okay. So as usual, we're going to check to see if there's an error first off. And if there is, we'll print it to the console. And if not, we're going to attempt to get the place mark or the address details. Now, just like with locations up here, place marks is an array, so it could return more than one. But again, just like with locations, we can just take the first and use that to get our address details. So to get that, we'd use place marks, and then this isn't optional because we don't know whether or not it's going to return a valid address. It might be that they're in the middle of the desert or somewhere that doesn't have geocode information attached to it. But if there is, we want to get the first item in the array. And what I'm going to do is set up an if-let statement like that. So if this works, then we'll be able to process something. If not, at least we won't get a crash by attempting to use placemark 0 when it doesn't exist. And for now, let's just print the placemark variable and see what sort of information this gives us. All right, let's give it a go. So just to recap, we're using CL geocoder, and then we're reverse geocoding a location. So we're going from a location to an address, hopefully. And the CL geocoder method returns place marks and possibly an error message. We're checking to see if the error message is non-empty. If it is, then we're printing that so that we know what's going on. If it's not, then we're checking to see if we've got a place mark in the first entry of the place marks array. And if we have, for now, we're just printing it to the console. Let's check it out. And here we go. So just a reminder, this isn't my actual location, but it's the location given on the simulator debug location setting there. So at the moment we've got a freeway drive. So we can say we're supposedly on the I-280 north near Redwood City in California. And you can see we are getting the occasional error there. So we definitely do need to be able to handle our errors. All right, I'm just going to stop that so that we can look in a bit more detail of what information we've got here. So we've got a road name and here another road name. In a normal address, we'd likely have a number and road name right at the beginning there. Then we've got a city, we've got a state, and we've got a zip code, and we've got a country. It's not obvious though from all of that how we can actually extract that data. And that's because placemark is a special object. It's not like an array. When we print it, we just get all the information next to each other. But if we want to get the individual pieces of information, we need to get them directly from the placemark itself. And we can get them by essentially knowing the names of the items of data that we need. So placemark.country, for example, obviously gives us the country. And then we have things like the thoroughfare, the sub-thoroughfare, the sub-administrative area, which is essentially the state for a US address at least, and then the postal code will give the postcode or zip code. So each of these should exist, but we don't know for sure that they do. So to be absolutely safe, we should check for each of them. So the way I'm going to do that is start off with a let statement, and we're going to work our way through and set each of them initially to an empty string, and then we're going to check to see if placemark.sub thoroughfare is not nil. Then we'll set up sub thoroughfare to equal placemark dot sub thoroughfare. And using this setup, even though it's a little bit long-winded, we can be absolutely sure that we're not going to get a crash if, for example, the country isn't included for some reason, or a particular sub-locality, or indeed the sub-thoroughfare. Ah yes, fair point. We should make that a var, as we're going to change it later on. And we should also unwrap sub-thoroughfare, which we can do because we've just checked up here that it's not nil. Notice that we can't quite use an if-let setup because we want sub-thoroughfare to exist either way, because we're going to be combining them all into a single string. So although there are other ways to do it, I think this is probably the simplest. So let's do it again with thoroughfare. Set it equal to an empty string, and then if placemark.thoroughfare is not nil, then we'll let thoroughfare be equal to placemark.thoroughfare unwrapped. Okay, I'm just going to copy that for the next one, which is the sublocality. And in fact, I'll just copy and paste that throughout to save you having to watch me type. There we go. And after sublocality, we have sub administrative area. Just check that it's there. There we go. So that's essentially the state. Then we have the postal code. Got an issue there. Okay, maybe I did spell it wrong. Good idea to use the auto predict just in case. Okay, then we've got the postcode. So we'll set that to an empty string. And if it exists within the place mark, we'll update the empty string to that. And then finally, we have the country. So placemark.country everywhere. All right, and then finally, we're going to combine all of those into a single print statement where we're going to print sub thoroughfare, which is essentially the number, and then thoroughfare, and then we're going to print a new line, which we do with \n, as we saw a couple of sections ago, and then we'll have the sub locality, new line, then we'll have the sub administrative area, there we go, and a new line, then the postcode, new line, and finally the country. All right, so let's now take a look at that. So it was fairly long-winded, but we really do need to go through each of these and check that they exist. Otherwise, there's a fair chance that an address will be returned without one of these, and if that happens, then our app will crash, which we want to very much avoid at all costs. And there we go. So you can see it's updating there. We've got the road name, the sub locality, the sub administrative area, and then the postal code and the country. And you'll see if I update that to a different location. So let's go on a bicycle ride instead. We now have a new address with one infinite loop being the sub locality and sub thoroughfare, or sorry, sub thoroughfare and thoroughfare, which reminds me I should put a space in between those two. There we go. So that's how we get the address and address details from a location using CL Geocoder. Now let's find out what the location aware app that we're going to build is going to look like. And here it is. So it's a pretty simple app, as you can see, a very simple user interface. All we're doing is displaying the latitude and longitude, the course or direction and speed, the altitude, which is always 0 on the simulator here, and then the nearest address, which we're extracting from the reverse geocode. So that's it. Pretty simple. I'll leave it to you to give it a go. Best of luck. All right, hope that worked well for you. I, of course, am going to start by building a new project. And of course, we're going for a standard single view application. Product name is Location Aware, and we'll save it in the desktop. So the UI for this particular app is obviously pretty straightforward, nothing too complex going on, but it all centers around getting the user's location. So let's set our app up for that first off. So we'll jump over to build phases, link binary with libraries, add a new library, and then search for core location. That's step number 1. Step number 2 is jump over to info.plist and control click and add a row. And this time I'm going to show you a different way to add the options. If we scroll down here, down to privacy, you can see we've got the location always and location when in use descriptions right there. So instead of typing in the name of the key, you can just select it from there. So that's location always, and let's select when in use as well. So the always I don't really need, so I'm just going to leave that as I don't really need this because I'm not going to ask for it anyway. And this is to give you information on your current whereabouts. All right, now over to viewcontroller.swift, and let's set ourselves up to get the location. So as before, we're going to import core location, and we're going to add CL location manager delegate to our view controller so that we can control the location manager from the view controller. Then we'll create our manager variable, which is going to be a CL location manager, but not a delegate, just a manager. Then we do the setup over in view.didLoad. So we'll set the delegate to the view controller or self. We'll set the desired accuracy to be KCL location accuracy best. Then we'll request the in-use authorization. And finally, we'll start updating the location. And then just underneath view.didLoad, we'll set up the did update locations method. And as before we write anything too complicated, we'll just print the locations. All right. So let's jump over to iPhone 6s and take a look and just make sure that we've set everything up correctly and we're getting the user's location. And here we go. So it's requesting to get the location. So let's allow it. And there we can see it's picking up that location. Fine. All right. So now we need to decide what information we're going to display for the user. So here we've got the latitude and longitude, which I think we should display. And we've also got the speed and direction. And we've also got the altitude in there as well. So let's give the user all the information that we can. And let's get building. So I'm going to start, well, in fact, pretty much all of these are going to be labels. So let's have one at the top with the title of our app, location aware. Make it a little bit bigger. Drag that out, center it on the blue lines, and then more importantly, set up the constraints and center horizontally. There we go. And then I'll add my first information label, and this is going to be latitude. And then straight underneath, we'll keep them aligned to the right. Longitude. Keep them coming. A little bit of space out to kind of have a different section for course and speed, both as they are related to movement. Then we'll have a third section for altitude. And finally, we'll have a spot for nearest address, which we'll keep centered there. All right. Next, we'll add in all the labels that we need for our information. So they'll all just say label for the moment. There we go. And for the address, we'll stretch it all the way to the edge and give it as many lines as it needs. Okay, so that's our UI, basic as it is. And of course, we're not really worrying about auto layout here. We're more focused on just getting the information. So let's grab all of these. We'll have latitude label, longitude label, course label, speed label, altitude label, and finally address label. Possibly I dragged that to the wrong place. Try that again. There we go. Okay. All right, and now we're ready to go. So let's jump over to viewcontroller.swift and update our labels with the correct information. So as before, if let location equals locations 0, then we have a location to work with. So as before, we'll create a variable called location, which is just going to be the first location and usually the only one returned by didUpdate locations. So then we'll just check for the existence of each of the items of information that we want. And if we have it, we'll display it on the appropriate label. So if location dot coordinate dot latitude is not nil, then we'll set, and then we'll update our labels with the values. We don't need to check whether the values exist because the type CL location always has a latitude, longitude, course, speed, and altitude. So we don't need to worry about those. We can just update the labels directly. So we need to use self because we're in a closure here, something happening away from the main thread. So we're setting the text of the latitude label to, and remember this is going to be a float. So we need to convert it into a string, which we'll do using string location dot coordinate dot latitude. There we go, and the rest really just follows from there. So self dot longitude label dot text, it's going to be a string location dot coordinate dot longitude. Keeping going, self dot course label dot text, it's going to be string location dot course. Nearly there. Self dot speed label dot text is going to be string location dot speed, and then self dot altitude label dot text, it's going to be string location dot altitude. And there we go. So let's just quickly run the app and check that all of that is working. Those should now update fine. Of course, we won't have the address information yet. We'll do that after we've checked that this is all working. And there we go. You can see the details are showing up here. Obviously, we've got a bit of an issue with the width of the label, so we'll fix that in a minute. and the altitude is fixed at 0 here, but that would give you a correct value on a real phone. Okay, so let's quickly jump over to main storyboard and fix those labels. So I'm just going to spread them out to the end of the screen. And also, while we're here, we don't really want the word label to appear while we're waiting for the first result to come through. So I'll just get rid of the word label there. Okay, so I'm not going to run that again. I'm pretty confident that that will work. Let's now jump to viewcontroller.swift and get our address using reverse geocoding. So as before, we'll use CL geocoder and then reverse geocode location. The location that we want is of course location, and then double click on the handler. And there we've got our placements array and our error. So just as before, we'll check for error first. So if error is not nil, then we'll just print the error. If it is nil, then we'll check for the existence of our place mark. Actually, it should be place marks rather than placements. So remember, even if we don't get an error, we might not get a place mark. So we should check for its existence before we do anything with it. And then I'm going to use a slightly different method this time to collect together all the data. I'm going to start with creating a variable called address, which will initially be empty. And then, as before, we'll look for all of the options and see if they're not nil. And if they're not, then we'll append them to the address. And this one will pop a space on the end. And yes, we should force unwrap that, which is fine because we've checked that it's not nil. So this just appends the subthoroughfare to the address with the space as well. And then similarly with thoroughfare or the road, if that's not nil, then we'll append that to the address. And this time we'll add a line break at the end. And then I'll just copy that to speed things up a little bit. So now we'll look for a sub locality and sub locality. And yes, don't forget to unwrap those. Then we need our sub administrative area. Almost there now. So we'll have the postcode. And finally, the country. There we go. So a slightly quicker way of doing it rather than creating a whole bunch of variables if we only need to use the variables in one place each. And then we just need to update the address label. So we use self.addressLabel.text equals address. And there we go. That should do the trick. So let's run it and take a look. And there we go. You can see everything's displaying nicely: latitude, longitude, course, speed, altitude, and even nearest address. So that really does give the location aware user all the information they could possibly want about where they are. As always, there's a lot of ways that you could improve this app. The most obvious one might be to add a little map at the bottom and show their location on the map. But that's as far as we're going to go with this particular app. In the next few videos though, we'll be working towards a much more advanced app which uses location, maps, and a lot more to allow you to store your favorite locations. To do that though, we'll need some advanced segue skills, and that's what we're going to learn in the next video.